Hi, everyone. Welcome to the live Q&A, and thank you for attending this session this week. So with that, we'll have our panelists join us for now. Hi, everyone.
Hello.
So to get us started, I'll do a quick roundtable, a little bit about where you're from, what's the weather outside, so that we can get a little bit situated. So name is Francois, so I introduced in the video. So I'm currently located in Bellevue. I am back in the office. This is something brand new world. So we'll see how it goes. Weather in Bellevue, this is in Washington State, was a little bit rainy this morning. So, and then I'll move to Bin.
Hi everyone, my name is Bing, and now I'm still working from home. I haven't gone to the office yet. I'm in the Seattle area, and today's weather is not very good though. It's a little sunny and a little cloudy. Hope you guys enjoy the videos today, and we are here for answering any question you might have.
All right, Kumar.
Hey everybody, I'm Kumar. I've been at Meta for a couple of years, and currently I'm still working from home. Super excited to get back to office, just not yet. And I'm from the city which has the best weather in the world. You guessed it right, it's Seattle. So yeah, I hope you enjoyed the presentation, and I'm super excited to answer any questions that you may have.
All right, Arushi.
Hey everyone, Huang here. I'm actually at Menlo Park, California. And weather-wise, actually, we're having Seattle weather this week. Super excited to talk to everyone today. I hope you enjoyed the talk.
Great. Ivan.
Hi folks, my name is Ivan. I work for Microsoft. This is my second tour of the company. I'm in Bellevue. I'm working from home, but I'm here in Bellevue, so I have the same weather as everybody apparently.
Okay, and I'm going to finish this roundtable with Shiv.
Hi everyone, I'm Shiv, and basically I'm also calling in from the MPK area, Menlo Park. And like Haji mentioned, although we're in sunny California, this week is a little bit rainy. Super excited to be here.
Great. So let's move to question. We have a bunch of questions to cover. I'll try to go in some sort of meaningful order. So let's figure this out. So I'll start with Ivan and the Cosmos Big Data platform. So something that comes to mind is like, how big is the biggest job running on the system?
Yeah, so we have the value proposition of this. It's extensibility and scale and cost, right? So one of the things that happens on the system is like instead of having like a lot of little jobs that deal with data, we allow people to just basically dump data on the engine. So the answer to that is it depends. By number of containers, is something around 3.8 million containers on a single job. Okay. In terms of input size, is 1.5 to 2 petabytes of data on a single job. And in terms of record size, the biggest thing we have comes from Bing, and they have this record that a single column has 120 megabytes. Like one field on the column on a single record is 120 megabytes. And I kind of know this stuff by heart because this is what makes the system break. Yeah, the maximum number of inputs we have is 50,000 files in one job. That's about the biggest thing you're gonna find. Not all on the same job, but cross jobs.
So when you say like 2.8 million containers, like is that in the same building? Because you kind of have an integrated stack, or it's spread out, few building, few region. How does that work?
Yeah, it's over multiple subclusters, but it's a same building. Yeah.
Same building. That's a lot of container in that building.
It's a lot of containers. So that's why we need those clusters, right? That go to 60,000 machines and whatnot. This is the reason we need it.
Okay, great. Let's move to Delta for a bit. And that's something that's very dear to my heart, is about low dependency. So can you guys, either Kumar on Bin or Bin, can you guys like elaborate around how do you keep your service low dependency? Like we have like a super high code velocity at Meta. And how do you make sure that it remains low dependency? You might be low dependency today, but tomorrow it might not be.
Yeah, I can take that. Thanks for the question. So to begin with, we ensure to not take any dependencies on services which are higher in the dependency stack. Most of our dependencies are soft dependencies, meaning that we have appropriate failover strategies in place in case our dependencies experience an outage. And in order to ensure that we don't violate our dependency expectations, we constantly exercise service recovery drills in severely degraded environments. Essentially, we simulate environments where we only allow whitelisted outbound traffic, the traffic that we expect to go out from our service. This way, we are able to validate our low dependency guarantees. Alongside this, we also have a recovery mode service setup, which would have a limited feature set, essentially only supporting emergency operations in disaster scenarios. I hope that answers the question.
Great. Let's move to ACS for a bit. Maybe question for Shiv or Arushi. ACS is super important, and we had during the broadcast on the Facebook Live page, there was a lot of comment. People did appreciate the analogy of using transportation tickets and so on. So that was great. So for ACS right now, how many use cases are you guys handling today?
Yeah, I can take that question. So for ACS, actually, we have more than 10 use cases running in Facebook now, such as telemetry service to collect reliability or system health data. We also, as we already talked in the talk today, we have the general logging for product metrics. And there are some location surveys where the service is provided based on proximity to the user. And of course, there are many privacy-minded features where the identify service is one of the core requirements. Over time, we're still adding more use case to this privacy-enhancing technology. It's really just the beginning.
Great. Ivan, I want to go back to the concept that you started at the beginning of your presentation about integrated design. So, and the question is why do you feel like you need to go down to the DC design and hardware management? Usually people kind of go in standard racks and standard colos. So what was the big compelling factor here?
This is an interesting thing, right? The standard rack and standard colo, I think none of the large companies do that. If you go around and you see whatever is publicly shared about, Facebook does a fantastic job sharing all the design. There's very little on the whole thing that is standard. Amazon is kind of more guided, but they share things as well. Microsoft has public design shared as well. But in my case, it's it's a number of things. So one, being able to explore the topology of the data center. And the second one is to be able to have a higher availability and better utilization by being aware of what's going on under us, right? I think the secret for this is coming back into low dependency as well, is you have a proper layer on this. If you have the proper abstractions, you don't have to have a tight dependency to be aware of what's going on. And that's a part of this work that I'm fascinated about. How can we have the most efficient sizes and designs without actually adding too much of the complication of what traditionally fully integrated design would be?
All right, cool. Let's move back to Delta. So can you elaborate a little bit more on how your system will restore from backup? Because it's going to happen one day.
Yeah, I can help on this question. So once Delta has all its blobs back up into some cold storage, for example, Darkstorm or production Isilon we have, Delta could easily retrieve those backups during disaster recovery. So basically we have two main components for reading blobs during the service restoration. The first part is the Delta service is able to serve some ad hoc reads. So once a client reads blob that has not yet been restored by Delta, Delta will retrieve that particular object from the cold storage. And the second part is, except for this ad hoc read request serving, Delta has a long-running process which restores all the objects from the cold storage continuously until all the blobs has been restored for the service.
Great. Let's move back to ACS. So Meta has invested a lot in privacy. We've been very public about this. So it means that ACS is used in a lot of use cases that you covered earlier. So what are the scaling bottlenecks that you're seeing today in the system?
I can take this question. So actually one bottleneck we're actually currently seeing is at our credential counter, which is at our server's token redemption endpoint. Now, I think we mentioned in our presentation, we have this credential counter to ensure that a particular credential we see has not been over-redeemed. And we actually implemented this counter using ZippyDB, which is Meta's global key value store, and particularly using ZippyDB transactions. Now, although this kind of ensures that the credential counter is highly accurate, this comes at the cost at a much higher end-to-end latency just because of this dependency. In the future, it'd kind of be super awesome if we can implement like another mode of this credential counter so that maybe less sensitive use cases can utilize this less sensitive mode that could essentially tolerate a little more counter noise, but have reduced latency just for performance and capacity reasons. Another kind of issue is that ACS, since it's a multi-tenant service, we actually have capacity allocated in like the different regions. And we normally how it works is we work with use case teams on like a one-to-one quarterly basis, just to ensure that capacity is allocated in the appropriate regions. It'd be pretty cool if in the future we can move to like a global pool model where we allocate hosts in a global pool, and then they're just kind of dynamically allocated in the appropriate regions as per demand.
All right, so let's stay on ACS for a bit. So we spoke about like the bottlenecks in scaling. So let's talk about adoption. So what was the biggest challenge when you guys were like moving up the adoption across users?
Yeah, I can take this one too. So one of the biggest challenges in like ACS adoption, I think was actually the biggest challenge was client engineers would kind of have to understand the underlying crypto primitives of ACS and implement them in the relevant mobile platforms when just kind of integrating with us. And after our first like major integration, we basically realized that this was proving to be a huge problem. So this was like high signal for us that it's time we invest in a client SDK. Now with this SDK, we kind of abstract away all these like ACS protocols, the crypto primitives, provide high quality implementations, so that clients can just directly call these high level methods. This kind of allows engineers all over the company to leverage ACS without requiring them to have this maybe expert level crypto knowledge. And we actually built this SDK in both Android and iOS.
Great, some good abstraction. So let's stay on the privacy front, and then but let's go on to Ivan around like part of your presentation. You spoke about a variety of product. And I want to move a little bit from privacy to security. So how do you isolate these workloads? How do you make sure that the system remains secure?
Okay, so that is a multi-layered answer for you, right? So it depends. We have like a pretty wide variety of different customers. For some of them, we kind of isolate on the cluster. So if you're doing telemetry analysis and this does not contain personal identifiable data and whatnot, you're doing perf counters or let's say Windows release, I can go and put 50,000 machines and all the jobs can share those machines, and that's totally fine. We also have this engine also powers Azure Data Lake analytics, and so in that case it's external companies, and then the isolation is done with VMs. And we go all the way to national security clusters where we have air gap solutions, right? So one of the requirements when you work at Microsoft is you have to deal with a ginormous variety of customers that come with every single compliance requirement you can name, and a few I cannot name. So for each one of those, there's a different cost involved, and we have a slightly different solution.
Great. Let's go back to Delta. Let's talk about latency. So how does Dumbo or Delta handles the latency between regions?
Sure. So in global replication, we upload to only a few regions in synchronous fashion to ensure that at least some regions have the blobs before we respond back to the clients. We also have an asynchronous replication fleet, which is responsible for backfilling the blobs to all the remaining regions in an eventually consistent fashion. In order to ensure that each object follows the replication topology that it's supposed to, we have a service which continuously verifies each blob in every region to make sure that their topology is respected. In case some of the objects are not present or are corrupt in one of the regions, these blobs are backfilled appropriately.
Great. I'm going to go to a few questions that were just happening right now. I'll move to Ivan, and the question is like, what you show in your demo, is it like for newly written program, or the question is like, can you take old thread-based program and then decide to break things into containers and things like that? Do you have something that does that, like that will break like an old style program written at the beginning of the 2000 and have some logic to break it down?
So first thing is like that demo was taken in real time, right? So everything you saw me doing in Visual Studio, there's no editing on the flow of that. Like, it's F5, that's the time it takes and runs and whatnot. You cannot take just a simple piece of code and run it. You can, though, write a query to parse the data and use the scope thing. And what you do is you implement the function. So with that, you can take, any code you have. And what we're going to do is we're going to take that thing that is like, let's assume worst case scenario for performance, single threaded C++ or C code from 1992, whatever, right? You can actually spawn that as a function on that way. And what we're going to do is we're going to segment both the stages in parallel and the data. We're going to chunk the data and we're going to feed segments of the data into instances. So in that case, yes, I can take like whatever code you have and run that thing in thousands of containers. But you're going to have to give up your main function and you're going to have to use the script to glue this together.
Great. On the same type of question, you mentioned that like most of it is running Windows under the hood. Why not Linux? Any plan to support Linux in the future?
Yeah, so this is all on Windows right now. I mean, all the servers, everything runs Windows. We do have plans to run on Linux, and one of the reasons for that is machine learning. So if you go look at this, it's kind of like always in flux. People go, let's say, use pandas on Python, right? And they TensorFlow or whatever, right? And it's very common for someone to go and take the underlying C++ thing that powers the Python framework and hack some stuff or leave some resources on /var or whatever, right? And we have people like that working at Microsoft too. So one of the things that we want to do is to allow them to run those scripts with no changes, right? I think eventually people look at the rest of the system and say, oh, it's worth learning. But we want to make the system very, very welcoming for them. So yes, we should be running. And if we open source, I mean, it's like it's a no-brainer, right? If for us to open source this, it must run on our providers, and that implies Linux.
Great. I'm going to stay on the topic of open source, and I'm going to move to ACS. Any plan to open source ACS at some point? Because I could see like tons of other use case, in other industry and other companies and so on.
Yeah, that is a good question. So for ACS, that's definitely the plan. So the idea of this anonymous credential itself, it actually comes from the academic research, and we like to contribute back to our community for sure here. And ACS is really just one implementation of anonymous credential that also work at a meta production scale. And it can be an interesting example for other group looking to do the same. So our plan is really to modify the dependency of current ACS implementation and get rid of that meta specific dependency, and eventually release that over open source stack so everyone can take a look and probably take that as a good reference. Yeah, that is the plan.
Great. I'm going to stick to the open source topic. So the questions for the Delta system, in open source there's a comparison to the Gluster FS. So here's the question: does replication in Delta provide exact once guarantee? And the mentions that this is available in Delta, in Gluster.
Yeah, this is a good question. Inside Delta, we do guarantee that each message only be delivered once. And in the chain, for example, if the downstream is unreachable and upstream will try to retry the delivering of the message, probably after a period of time, the downstream still come back online, and we will try to disable that particular node with a pre-configured time. For example, if the host come back for 30 seconds, we'll try to disable that host. And then in this case, either the message will be delivered to the node after this concerning downstream, or the current node is already the new tail. So no more message delivery will be needed. And to the second question, whether Gluster still be used inside Meta. So the answer is no. Gluster has been deprecated inside Meta, and the use case for Gluster has been migrated to several other storage systems inside Meta.
Great. I'm going to move back to ACS. So what sort of future improvements for the system? What's next?
I can take this question. A good next step for ACS would be to leverage attribute-based keys. And now this project would enable us to kind of create verifiable sub-use cases, which allows us to control, basically create more finer grained ACS tokens. So basically by having these attributes, we can, we only have to provide, before we would have to provide transparency for as many keys as there are ACS projects. But with these attribute-based keys, we only have to provide transparency for the root key, and we could still ensure the trust of all of the sub use cases. So that's one exciting idea we have. Another feature improvement could be outfitting ACS with a distributed key transparency system. Now this would basically, the system would provide like an immutable and auditable log history for keys. So all users can ensure that ACS is kind of using these same global keys for everyone. Yeah.
Great. Now back to Ivan. There was a question around, what's the relationship with Azure in general? How do they link? And also, like, why not run this on Azure? And I think you kind of answered it into like, the integrated DC all the way.
We do for some properties, like the Cosmos, the biggest clusters we have, they run on bare metal because we actually predate Azure by, like, there was no Azure by the time we had this, right? This is 2003, 2005, and there's no such thing as cloud. So we built this, and a lot of the concepts went to Azure. And some of the workloads we built straight up on Azure. Like, I think the whole industry right now is looking into how to deal with Shrimps 2, for instance. And that is a requirement to have clusters in Europe. So our clusters in Europe run on Azure and use Azure VMs and our Azure infrastructure. The older clusters that we have, we're gonna run the machines to their life, and then stuff goes into Azure. It's like it's a value proposition, right? Scale, extensibility, and cost. So cost sometimes kind of like holds back migrations.
All right. I'm going to take one last question because we're almost at time. So the question will be for Delta. And the question is, let's see, how does data is verified? Like, do you do CRC checks? And what's the strategy, especially for the tail use cases?
Sure, I can take that. So yes, essentially, whenever an object is put in Delta, what we do is each of the links store the CRC checks for each CRCs for each of the fragments. So whenever a link has to serve a read, it essentially does two things. One is it verifies that that object is already present on the tail, and in order to ensure that we are only vending out the chunks which have been essentially replicated across the chain. This is to ensure strongly consistent reads. And once it has verified that yes, this chunk is indeed present on all links in the chain as it's safe to be vended out, then it does this CRC check for the CRC is essentially stored during the write flow, and before sending it out, we verify that the chunk is indeed intact. And additionally, other than this read and write flow, there is a runtime consistency check which is done for all objects on all links in the chain. In case we detect any inconsistency at any point in time, on-calls will get critical alerts, they will investigate the issues, and we have appropriate tooling in place to ensure that the objects are fixed.
Great, awesome. Thank you. Thank you, everyone. Thank you for the participation. Thank you for the presentation. Thank you to the audience for attending. I know it's a lot of time, so we appreciate everybody that attends and that watch these videos over time. With that in mind, just a reminder for everyone that the originally week 1 will be broadcast tomorrow, and then we will be back with another live Q&A. So thank you, everyone, and have a good day.